Hello, and today I'm going to be teaching you all about elements, compounds, and reactions. Firstly, let's talk about elements and atomic structure. For demonstrations purposes, we're going to be talking about the element calcium. An element is made up of three main parts: electrons, neutrons, and protons. It is important to know how much of each part an element has. To figure this out, we must look at the periodic table element of calcium, or whatever element you're using. To figure out the number of protons, we simply need to look at the atomic number, which is 20. So this is the number of protons. Neutrons are a little bit harder, but still generally easy. So first we need to get the atomic mass, which is this number right here. So we see it's 40.0, so I'll just round it all the way to 40. And we take this number and we subtract it from 20. So if we do 40 minus 20, it's obviously 20. So the number of neutrons is still 20. So this is right here, protons equals 20. Electrons are basically, they're really easy. They're just a number of protons. So electrons are 20 as well. An ion is an atom with an electrical charge. In order to form an ion with calcium, we would lose electrons. So you probably don't know this, but calcium has an ion charge of 2+. So in order to form an ion, we must lose 2 electrons to empty their electron shells and become positive ions, because when an ion comes together to form an ionic bond, they always join in numbers that exactly cancel out the positive and negative charge. Now we are going to move on to ionic compounds. We have two formulas here, Al2O3, or basically just aluminum 2, oxygen 3, and calcium chlorine 2. So first we're just going to do this one. So as I said before, there's two elements, aluminum and oxygen. And in order to name this, like get a proper name, we must simply take aluminum here. So let's write aluminum. Hopefully I'm spelling that right. And oxygen. And for the end of the last, for the non-metal, so we take the metal first and we do the non-metal, but at the end of the non-metal we add an I. So we get aluminum plus oxide. So the answer would just equal aluminum and oxide. So aluminum oxide. Now for the second formula, we have calcium and chlorine. So obviously calcium is the metal. And then we get chlorine, so chloride. So for this one, it'd be calcium chloride. So if we're trying to do the reverse version, we have calcium chloride and these ones. So I'm going to do this one first. So we have this, and we're trying to get the formula. So calcium has a charge of 2+, and chloride, or chlorine, has a charge of 1-. So now we just have to basically cancel them out until they both become equal. So we have 2+ and 1-. In order to make them equal, we basically just need one more 1-. So that means there's going to be 1 calcium and 2 chlorine. So that means we're going to get the formula Ca and Cl2. Because there's 2 chlorine and there's 1 calcium. Okay, for the next one, we have aluminum and oxide. So there's 3 here and 2. So obviously these will match up. And if we had another one of these, then this is more. So we have to do one more. And then now they're equal. So for this one, we get 2 aluminum and 3 oxide. So that one gives us Al2O3. Because aluminum 2, oxygen 3. Moving on to molecular compounds, we have CO and P2O5. So we're going to start off with CO. But in order to name a molecular compound, we must first determine what the elements and how much of each one there is. So for this example, there's just 1 carbon and 1 oxygen. But for the molecular compounds, we have to start with a certain prefix, which I will put up on the screen right now. For this example, it is simply a mono for oxygen. And we don't put a prefix on the first number because you just don't for molecular compounds. So if we do that, we'll get carbon, and then because of the prefix, we'll get mono and an oxide, because it still ends in the "ide," like the ionic compounds. So for the next one, we have P2O5. So that's phosphorus and oxygen, and there's 2 phosphorus and 5 oxygen. So for 2, we get the prefix di. So diphosphorus. And for the second one, we get oxygen 5. So diphosphorus pentoxide. should be it. In order to do it reverse, you simply just reverse the operation we just did. So if the first number doesn't have anything, or is like, so that means it's like 1, because, we don't add a mono for the first number. And for the second one, we just look at the prefix it has. So if it has pent, then it's a 5. So if we use this for this, we can see that there's 2 because of the dye of phosphorus. So we can already say that there's 2 phosphorus, so we get P2. And for oxygen, we can see that there's pent, or 5. So 5 oxygen. So P2O5. Now for this next one, we can see that there's nothing here, so it's obvious, so it's 1. So we can already put that C there. And for this one, it's also 1, and it's oxygen. So we get C and O. Our final topic is reactions. All reactions follow the law of conservation of mass. The law of conservation of mass basically states that all mass from the elements at the beginning of a reaction should stay the same at the end of a reaction. An example of a reaction is combustion. Combustion occurs when anything reacts with oxygen and burns. The reactant would be the oxygen and the thing causing the burn, while the product would be the product resulting in the reaction. For example, gasoline and oxygen, which are the reactant, burn and cause carbon dioxide and water vapor, the product. This reaction would be exothermic because of the heat being released from the burn. And that's it. I hope you learned something from watching my video, and that is all to learn today. I hope you enjoyed it, and thank you for watching.